Today we are moving on to our third type of transformation. We are going to be working with rotations. So our objective, to identify and use rotations. Couple definitions. A rotation is a transformation in which a figure is turned about a fixed point. The fixed point is called the center of rotation. I have a feeling most of us understand that rotating means to turn something in general. Anybody need more time with those definitions? Okay, so let's talk about the 2 D's of rotation. First one, direction. How can we turn objects? 2 different ways. We can turn them clockwise or counterclockwise. So clockwise meaning the way the hands of a clock would move as time goes on. So generally that would be this way. Counterclockwise would be, of course, the opposite of that, the other direction. Which is always, for whatever reason, harder for me to draw. So going backwards would be going that way. Are we okay with clockwise and counterclockwise? Okay, think about the hands of a clock. All right, degree is how far to turn the object. It's measured in degrees. So if you look towards the bottom of your notes, you'll see that at the bottom we're going to talk about rotating 90 degrees, 180 degrees. Counterclockwise, we'll also talk about doing those clockwise. You can technically turn objects at any degree. You could turn it 1 degree. It's not going to be a whole lot different. You could turn it 100 degrees. But we've got a couple set ones, 90, 180, 270, that we'll talk about that happen frequently. At least they're easier to talk about. If we were to turn something 360 degrees, what do you think happens to it? Good, it'd be in the same spot. Nothing really happens. We wouldn't be able to tell that we turned it because it would look exactly the same. Questions, concerns, need more time on this slide. Okay. On we go. After a rotation has been performed, the image is going to be congruent to the pre-image. Same size and shape. So far, that's been true with all the transformations we've done. If you translate, if you reflect, if you rotate, your pre-image and image are going to be congruent. That changes tomorrow. Tomorrow when we talk about dilations, we will not have congruent figures, but for now, we will. Okay? So let's just do some visual examples before we get into our coordinate notation. We are going to rotate these letters. We are asked to rotate the letter T 90 degrees and 180 degrees clockwise. Okay, so if we are going to rotate it 90 degrees clockwise, we are going to turn it basically on its side. So it would look like a sideways T. Try to make it bold. If we were to rotate it 180 degrees clockwise, what do you think it would look like? An upside down T. So we go another 90 degrees, making it 180 degrees. Should look like an upside down T. Which that actually is also like a reflection, right? Ends up looking the same way. We could keep turning it, and of course if we did 270, it'd be sideways the other way. 360, we'd be back where we started. Okay, the letter H, we are going to rotate it counterclockwise. So instead of going towards the right, I'm going to go which way? Towards the left. So we go towards the left, and we should have a sideways H. Try to make those a little bold. And then if we go 180 degrees, it would be upside down, but the letter H upside down looks the same, right? As a capital right side up H. Try to make these bold. Okay, and if I was a great artist, these would look like the exact same size and shape. I am not a great artist, especially with an iPad, so we just have to understand that. Questions, concerns about rotating? All right, we'll keep it moving. Often rotations are done on the coordinate plane centered around the origin and in a counterclockwise direction. Now, why they chose counterclockwise as the primary direction, I don't know. We will talk about both counterclockwise and clockwise. There are coordinate rules to use to find the new ordered pairs for the rotation. Just like yesterday when we looked at the relationship between the X and Y coordinates from the pre-image and the image when we did a reflection. Those rules were pretty simple. If you reflect across the X-axis, the X coordinate stayed the same. What happened to the Y coordinate? If the X stayed the same, the Y had to change signs. And then, of course, with the Y-axis, the Y coordinate stayed the same, and the X coordinate had to change signs. We have the same kind of rules for rotations. Are we ready to see them? Okay, you might have to add a column and a row to get everything in there, so here's what I mean. Yours only has 90 and 180 counterclockwise, so I would add 270 at the bottom. I would also make space to add in the equivalent clockwise rotation. So you might want to split your second blank boxes to fit this in. And then, of course, we have the rule about what happens. So I'll give you a minute to get your table expanded and filled in, and then we can talk about them a little more. All right, so let's just talk about what these rules mean. X comma Y refers to our starting point. So X's could be positive or negative. Y's could be positive or negative when you start. Just wherever you start. For 90 degrees counterclockwise, which is the same as 270 clockwise, they're going to switch spots, and whatever was originally the Y coordinate is going to change signs. So two things happen. They swap, and the original Y coordinate changes signs. 180 is easy because it's the same both directions, counterclockwise or clockwise, and all that happens is you negate or take the opposite of both X and Y. They don't move, we just change their signs. 270 counterclockwise is the same as 90 degrees clockwise. Again, the X and Y are going to switch spots. This time, whatever was originally the X number changes signs. Yes, it is a little confusing, which is why these rules will be helpful to have readily available. Anybody need more time getting this copied into their table? Okay. Give the new coordinates after the rotation. So, we start off with the coordinates 3, -2. We are asked to move it 90 degrees counterclockwise. So 90 degrees counterclockwise is when x comma y went to negative y comma x.
Wait, can you repeat that?
Sure, I also wrote it up there. X comma y goes to negative y comma x for this rotation. So the x and y are going to switch spots, and the original y coordinate changes sign. So what are my new coordinates going to be? 2, 3. So the 2 and the 3 switch spots, and what was originally the y, which was negative 2, changed signs to become a positive. Okay? Negative 5, 4 under a 180 degrees counterclockwise rotation. 180s are my favorite because all they do is switch signs. So what does it become? 5, negative 4. Switch both signs and you're done. Okay, the last one is the point negative 1, negative 4 under a 90 degree counterclockwise rotation. So that's the same type of rotation we did up here. Same rule. So the x and y switch places, and the original y coordinate changes sign. What do we end up with?
4.
Good. 4, negative 1. Questions about how these rules work? Ready to move on. Indifferent to everything. Some of us seem that way. It's all right. It's Wednesday. We're getting through our week. Graph the figure, rotate 90 degrees counterclockwise, give the new coordinates, and plot them. Okay, so the easy thing to do is to graph our original figure. So where is the point negative 4, 4? Okay, so x comma y, so somebody said it correctly, left 4 and then up 4. Left or right comes first, then up or down. Negative 2, 3. Left 2, up 3 is S, and then T is at negative 3, 1. Good. T. All right, so based on where we're at right now, which quadrant do you think we're going to end up in when we rotate 90 degrees counterclockwise? We're going to end up below, right? The quadrant below where we started off. So 90 degrees counterclockwise, we know we should end up down here. So again, the 90 degrees counterclockwise rule, was the x, y goes to negative y comma x. So I'll switch colors. So where is my r prime point going to be? Well,
Wait, are you asking me what the number is?
yes.
Negative 4, negative 4.
Good. Negative 4, negative 4. Yes. S prime, where is it going to be? What's my first coordinate? Okay, negative 3, comma, negative 2, and T prime. Good. All right, then we just have to plot them. Of course, we already discussed that they should all end up in this bottom quadrant here. R prime, S prime, and T prime. So we should be able to see we took this point up here and we turned it down to the bottom. Took S and turned it down here. Took T and turned it down. Questions, concerns? Now, this is not something you necessarily have to have in your notes or drawn here, but the whole reason that this is considered a 90-degree rotation, I'll show it in blue, is if we take a point from the origin and we place a line that goes through T, and then we go back to the origin and place a line through T prime. What kind of angle does this blue angle look like? A 90-degree angle. That's the whole thing. Is that if we were to make those lines, that these are 90-degree angles. That's why this is called a 90-degree rotation. And we could do the same thing going through S, if it wanted to let me do that, and S prime. Again, 90-degree angle. Same thing with the R and R prime. So if you're wondering why it's called a 90-degree rotation, that would be the answer. Questions, concerns before we continue? Okay, on we go. Again, we've got points A, B, and C. We are going to graph them. Rotate it 180 degrees counterclockwise, and then give the new coordinates and plot them. So eventually we'll have an A prime, B prime, and C prime. First, let's plot ABC. The point 1,4 is? Careful. Right one up 4. Left or right first, then up or down. 2, -3. Right 2, down 3. And 2, -1. Left 2, down 1. All right, that's our initial triangle ABC. Now let's work on rotating those coordinates. So if we're rotating 180 degrees counterclockwise, remember that's one of the easy ones. What happens to X and Y? They change sign. So if they were positive, they become negative. If they were negative, they become positive. So my new coordinates for A prime are -1, -4, B prime. -2, +3, C prime. 2, 1. Good. I'll switch colors to graph those points. Now, again, when we rotate 180 degrees either direction, we expect our figure to do what? Be upside down. Good. We expect that it would look like it's upside down. -1, -4. It's down here. A prime. -2, 3 is up here. And 2, 1 is over here. C prime. Connect those. Oh, I forgot my prime. There we go. Okay, and it does up here that we just took it and flipped it around upside down. Questions, concerns? Confusion of any kind? Warm, fuzzy feelings? Yes, ma'am.
It's like, what section is this? Like 4.1? It doesn't say.
Yeah, this would correspond to section 11.8 in your textbook. That's what this unit of transformations takes, one section out of a few different chapters, just because they sprinkled in the transformations throughout the book. We thought it made more sense to do them all together. Other questions, concerns?